I'll start recording. I'll hide the cameras. Okay, so looking at some word problems. So the first section you'll see in Deltamath today, they just want you to write a systems of equations. So you're just going to set them up. The second section will be very similar, except you will actually then solve using substitution or elimination. Or if you really want to, you could even put them in Desmos and just look at your graph if you don't feel like doing the substitution or elimination today. But you definitely want to make sure you're good with that. Hopefully from that worksheet from last week, you're pretty comfortable with doing substitution elimination because you'll see that on your small quiz we'll have this week. But looking at this problem, we have Jose is working 2 summer jobs. He makes $10 per hour washing cars, $9 per hour walking dogs. That's pretty not a bad gig. Last week, Jose worked a total of 13 hours and earned a total of $122. We're going to write a system of equations that could be used to determine the number of hours Jose worked washing cars last week and the number of hours he worked walking dogs last week. Define the variables that you use to write the system. So one thing you got to be very careful in Deltamath is whatever you pick for your variable. So if you whatever you pick, like if you do a lowercase or a capital, make sure when you write your equations, you use a lowercase or a capital. So whatever you put in these 2 boxes here, make sure you type them the same way when you're writing your answer here. So you kind of like the first thing you want to see is like kind of what 2 things are we dealing with? We're dealing with washing cars and we're dealing with walking dogs. So I'm going to let C equal, and then there's a drop down, but this would be how many, because we're talking about like the number of hours he's doing something. So it'd be, I'll let C be the number of hours he washed cars. I'll let D be the number of hours he walked dogs. If you don't like using different letters, you could always just use X and Y. But I kind of like to sometimes make them the letter that I have in the problem. So this is where it can be a little bit tricky. You kind of want to see what's happening in the problem. Usually it depends on the kind of the word problem you have, but a lot of times you have a total quantity, and then sometimes you might have like a more specific. So you want to be able to pull out 2 equations. So like, for example, here we have that he worked a total of 13 hours and he earned a total of 122 hours. So since I see 2 totals, I know I'm going to have 2 equations. Like one equation is going to equal 13 for the number of hours. One's going to equal the total amount of money. So for the first one, we just have C plus D, because that's the number of hours he washed cars. That's the number of hours he washed dogs. So we know there's 13 hours total. So my first equation is based on the number of hours, like total number of hours. My second equation is going to be based on the money amounts. So his total amount of money was $122. So if we look up here, he makes $10 per car, per hour of washing cars, and then $9 per hour washing or walking dogs, not washing dogs. So these would be our 2 equations. Like I said, one thing you got to be really careful on Deltamath. Like for example, if I made this a capital C, this would have to be a capital C. It will mark you wrong if your variables aren't the same exact ones you put in the box here. But I don't think it matters from what I mess with, like what you do if you do X's and Y's or you pick like letters that represent the question. So let's just submit. Let's see. Okay, good. Didn't mess this one up, but let's look at a couple more examples. And honestly, there's not always like a set way, but a lot of times you're going to be having equations setting up a total, but you want to read and pull out 2 questions. And honestly, you usually just kind of get better at these kinds of things from just seeing more and more examples. It can be a little bit tricky, especially we'll see kind of how it goes today, but I'm going to kind of walk you through one more, and then maybe I'll kind of have you guys trying to help me go through one. This one says a paper company needs to ship paper to a large printing business. The paper will be shipped in small boxes and large boxes. So those are kind of the 2 things we're looking at. If we had paper and pencil, I would try and kind of model. You should try and underline things in the problem. But they tell us each small box of paper weighs 25 pounds. The large box weighs 50 pounds. There was a total of 22 boxes, and we have a total of 925 pounds in terms of the weight. We want to write a system of equations, blah, 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 to find the variables. So first off, we have small boxes. So I'll do S. And we're talking about the number. We're trying to find the number. A lot of times they'll tell you at the end of the problem what they're looking for. Not always, but we're trying to determine the number of small boxes and large boxes. So usually the last sentence, it's not always true. I mean, they could just switch it up, but usually the last sentence is the part where they actually ask what they want in terms of word problems like these. And I'll do L, oops, for large boxes. So this one's very similar. We have a total number of boxes and we have a total of weight. So it's pretty much the same idea. We're going to have basically a total equation, or we're going to have an equation for weight. So for the total, it's just going to be S plus L. For the weight, like you want to put the weights in front of the variables. So each small box, oops, is 25 pounds. And then each large box is 50 pounds. But then like when we get to the next section, you'll actually be solving these. So maybe I'll submit this. Maybe we'll look at a problem from the next section just to kind of see how it works. So this one's very similar. Here, I'll pull up a sticky note so I can write the equations. Crap, let me stop sharing. Let me make sure I'm sharing my screen, not just the Chrome. So you can see hopefully the sticky note I have here. All right, so this question, we're going to set it up, and then we're actually going to solve the equation. So maybe I'll get some feedback from you guys if anyone wants to put in the chat or kind of look at what we're looking. But so first off, if we read this, so Abby and her children are going to a movie. They bought $71.50 worth of drinks and pretzels. Each drink costs $4 and each pretzel costs $4.75. She bought a total of 16 drinks and pretzels together. Determine the number of drinks and the number of pretzels that Abby bought. So I'll just get a setup. We're going to do D equals the drinks, P equals the number of pretzels, and we're focusing on the number. So I guess technically I should put this the number of drinks. For example, you could be solving for the price in the system, but we're interested in quantity here. So has anyone got like one of our first equations? So it's kind of similar to what we've seen. We've got a total cost and we've got a total quantity, kind of. So if anyone wants to put in the chat, has anyone got an idea for any of the equations? If you don't mind using D and P for our variables. And the chat is, there it is. Pull up this in the chat. I don't know. All right, no chat for us today. Oh, there it is. It just popped up. Oh, perfect. And nearly at the same time, got Aaliyah and Aslan, so thank you. So I agree with that. Would be kind of like I would call it like our money equation. Oh, actually close. Since it's our money, like we got to put like, because you just have like the number of drinks plus the number of pretzels. You want to put those, when you're talking about the money equation, you want to make sure you put the money with each variable as well. So actually, you guys are close. That'll be, but that's good for our quantity one. So Michaela and Aaliyah got the quantity. So one of our equations is this. But for the one that equals 7150, don't forget to put your prices. Fortunately, this one's going to look a little bit messy. So we're definitely going to want a calculator. So since it's like this money equation, make sure you include the prices of like the individual items, if that makes sense. So close on that one, but common mistake. So now we got to solve this. So you could either use like elimination or substitution. It's kind of your choice. I personally like elimination more myself. So I'm going to do elimination if that's cool. So I'm going to multiply this first equation by -4 because that would let me cancel my D's. So I'm just going to write my new equation below. So I would have -4D minus 4P equals 16 times -4 would be -64. So then we could eliminate our D's and we could add together our P. So we would have 0.75P equals, and I do this right. Oh, I forgot my negative almost didn't come over. So sorry, this is a negative 64, not a positive 64. So we would do 7150 minus 64. That would be 750. So if you solve this, hopefully the variable, I mean the decimals don't make it too bad, but you would get 10 is your P. So we had 10 pretzels. I mean, and then it's pretty simple from here. I mean, you would plug it back into this original equation, but since there's 16 total, that means there would be 6 drinks then. Like you plug it back in. I'm going to stop recording.